brothers, today we will learn about the function of a Mosfet. I have taken a desktop Mosfet. I have taken a desktop Mosfet and it is N channel. How to prove it is an N channel? Now I'll keep the multimeter in diode mode. I'll keep red probe at source and black probe at drain. Okay, red probe at source and black probe at drain. It is showing value 302. Okay, that means reverse the probe, no value. Red probe at source, it is showing value. You can see the value 290. You can see red probe at source, black probe at drain, it is showing value 297. That means it is an N channel value, and drain to gate, no value. So this line is my gate, this line is my source, this line is my drain input. So how I have connected? I have taken a common ground. I have connected all common grounds. What are the common grounds? One ground of my eliminator, which I am taking a input voltage. One ground is of my DC power supply. Okay, one ground of my multimeter. So I have connected all three common grounds. Okay, I have connected in a single wire. Now let me give an input. See, let me give an input. If you see, this is my input. I have given voltage from drain. Okay, if I give input, my input voltage is, you can see, 16 volts. You can see 16.36 volts is my input. Let me see the output. I have no output. N channel Mosfet, when it will go to on condition, the Mosfet will go to on condition if the voltage is more, if the voltage is positive. That means this is an NPN transistor. What it is? NPN transistor. This is an NPN transistor. So if I give a base voltage as positive, this will go to on condition. Okay, let me give a DC power supply. Switch on the DC power supply. In DC power supply, if you see, I have given 3 volts. Okay, my input is 16.46. Input is 16.46, but my DC power supply is 3 volts. This DC power supply I have given to the gate. DC power supply given to the C. Let me check the output. If you check the output in the source, it is showing me 2.23 volts. That means this is a threshold voltage. Why? The field effect generated in between the source drain, the field effect is very less. The field effect is generated by the gate. Okay, how this Mosfet will go to on condition? Either the gate voltage should be equal to the drain or more than drain. Okay, more means up to 30 volts it will accept, positive. Okay, now gate voltage is 3 volts, that's why 2.26 or 2.2 volts. Now let me increase the gate voltage to 5 volts. Now if you see, I have increased the gate voltage. Okay, my input voltage is same, 16.5 only. Now let me see the output. Output, it is 4.14. That means now threshold voltage is matching almost near to my DC power supply voltage. Am I right? Now let me come equal to 16 volts. Let me come equal to 16 volts of my input voltage. And 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I have given 16 volts. What happens to this Mosfet? Let me check the output voltage. Output voltage, you see, 15.14. Okay, 15.14. What is my input voltage? 16.5. Now I have given almost near the same. Let me increase this to 17 volt. What will happen? That means I have given the gate voltage more than the input voltage. So input voltage is 16.5. Let me check the output voltage. You can see everything is same. Let me increase to this to 20 volts. I have given the gate voltage 20 volts. I have given the input voltage more than the I have given the gate voltage more than the input voltage. Let me check the output voltage. If you see, output voltage is 16.48. If you see, my input voltage is 16.48. So almost matching. What is the proof? What is the concept of this theory? The concept of this theory is if I give a input voltage, to switch on this MOSFET, the gate voltage should be equal to the input voltage or more than the input voltage, then only I will get the output voltage. This is the theory. Okay, this is how you have to follow further. This concept you can see in AX1 motherboard schematics. When we are tracing 1.5 volts, there was with the help of 3 volts 1.8 volts was generated only with one MOSFET. So with the help of the threshold voltage, we can design our required voltage. Let me reduce to this to 2 volts. Let us see what will happen. I have reduced it to 2 volts. Let me see what happens if I reduce to 2 volts. The gate voltage I have to reduce, and input voltage is 16.5, and my output voltage, you can see it is nearing to 1.25. It has its own calculation, brother. It has its own calculation which will reduce the threshold voltage. We have a chart also for this. Thank you for watching. Keep sharing, like it. May God bless you. This is Mohammed Solutions.